Okay, so let's look at solving exponential functions. When you're solving exponential functions, you want to create a same base situation. And so looking at number 35, we have a base of 64 and a base of 4. Well, if I look at my powers of 4, I've got 4 to the first, 4 to the second, and well, lo and behold, 4 to the third is 64. So I can change both of these into a base 4. Move this over. So change 64 into 4 to the third power, but 64 had an exponent. So let's multiply times x plus 7. And this one is already base 4. So now I have base 4 equal to base 4. If you have the same base, you can drop those bases and you can solve the equation that's left. Okay, now let's distribute. We'll have 3x plus 21 is equal to 5x minus 3. Let's move the 3x to the other side by subtracting it, and that'll give us 21 is equal to 2x minus 3. To solve for x, let's get rid of our constant term. The opposite of subtracting 3 is to add 3 to both sides. And now we'll divide both sides by 2. And we'll get x is equal to 12. And that's going to be our solution to this exponential equation, because you can do 12 plus 7 is 19, and then 19 times 3 is 57, and then 5 times 12 is 60 minus 3 is 57. So both of those work out beautifully. Now looking at number 36, we have base 9 and we have a 27. The first thing you need to do is take that 27 and bring it to the numerator by changing its exponent from positive 1 to negative 1, because this number is doing you no good in the denominator. So you'll multiply negative 1 times 2w to get 27 to the negative 2w. So now we have base 9 and base 27. Well, if we try to change 27 into base 9, that's not possible, because 9 to the first is 9 and 9 squared is 81. So instead of trying to do base 9, we can change both of these into base 3. So I know I've got 3 to the first, 3 to the second, and 3 to the third. So change your base 9 into 3 to the second power, but multiply it to w minus 8. Change your base 27 into 3 to the third power, but multiply it to your negative 2w. Now that you've got both of these as a base 3, you can drop the base 3 and set your exponents equal to each other. So let's distribute. We'll have 2w minus 16 is equal to negative 6w. Now normally I would move the negative 6 over here because it's the smaller coefficient, but because I have a constant on this side and a coefficient on this side only, it would be quicker to solve if I would just subtract 2w from both sides. And that's going to give me negative 16 is equal to negative 8w. Now divide both sides by negative 8. Negative 16 divided by negative 8 is positive 2. So we get w equals 2 as our final solution here. Now when you look at number 37, you've got base 8 and base 48. So as we go through all of our numbers, base 8 is not going to happen, base 4 is not going to happen, base 2 will happen with this one but not with this one. So we're not going to be able to change these into the same base. Because we can't do that, we have to change it into a log instead. So let's do log. The base of your power is going to be the base of your log. Now loop around, and you'll have log base 8 of 48 is equal to n minus 5. We're solving this exponential equation, so let's add 5 to both sides, and we'll get n by itself. So we have log base 8 of 48, and we're going to take this whole thing and add 5 to it. Okay, when we do this, we're going to have to do math, alpha, math, and that'll give me my log base 8 of 48. Now, do you see how they already have the parenthesis here for you? So go outside of that parenthesis and add 5. If you leave it on the inside, you're actually going to find log base 8 of 53, and that's not what we're trying to find. So looking at our answer here, we have n is equal to 6.861. Now, we have 6, but there's a 5 behind it, so the 5 will round the 6 up to a 7. And this is my solution for n. And remember to go out 4 decimal places on anything that doesn't simplify. Now on 38, we're trying to solve for y, which means we first have to solve for the exponential function. So we have 2 multiplied to it and 11 subtracted from it. So let's get rid of the 11 first by adding 11 to both sides. Now let's get rid of the 2 multiplied by dividing both sides by 2. Okay, once we get to this point, we have to talk to ourselves and we have to say, can I make both of these equal to the same base? The only base that's possible is base 3. And if you think about it, you've got 3 to the first is 3, 3 to the second is 9, 3 to the third is 27, 3 to the fourth is 81. So we can't change these into a base 3. So we have to use a logarithm. So the base of the exponent is the base of the log. Log base 3 of 36 equals 4y. Now to solve for y, we're going to divide both sides by 4. Let's go to our trusty calculator, and since we're dividing, let's use the fraction key, and we'll do math alpha math to get our log base. Log base 3 of 36 over 4. So 1, 2, 3, 4. See, you've got the 6. It'll round the 4 up, and that's going to give me y equals 0.8155. Okay, 8,155 10,000ths. Okay, now looking at number 39, we have a base e. So we definitely can't change 65 into base e, so we have to use our logarithms again. So we'll have log base e, so let's loop around. Log base e of 65 is equal to our exponent of a plus 1. Now, one thing that I know is that log base e is the same thing as the natural log. So we'll have the natural log of 65 equals a plus 1. To solve for a, let's subtract 1 from both sides. So we'll have the natural log of 65 minus 1 is equal to our a. So let's go to our trusty calculator, and we'll have the natural log of 65. On your calculator with natural log, you have got to close the parenthesis, and then minus 1. Let's go out 4 decimal places on this. So the 3 is the 4th decimal place. There's an 8 behind it, so we're going to round that up to a equals 3 and 1,744 10,000ths. Okay, now our last one, we need to get e by itself. So let's add 7 to both sides. Negative 34 plus 7 is negative 27. Now let's get rid of the negative 3 by dividing both sides by negative 3. And that's going to give me positive 9. So once again, I can't make same base because you can't make a base e. So let's do log of base e and of 9 is equal to 2m minus 5. Now log base e we know to be the same thing as the natural log, so we'll do the natural log of 9 is equal to 2m minus 5. So let's solve for m by adding 5 to both sides. So I have the natural log of 9 plus 5 equals 2m. Let's divide by 2, and that's going to give me my value for m. So I've got m is equal to, since I have a fraction, let's use alpha x, and we'll do the natural log of 9, but you have to close the parenthesis on the natural log, and then plus 5 over 2. 1, 2, 3, 4, behind the 6 is a 1, so that will not round our value up. And that's your final answer.